Hello, Year 10 Triple. You haven't got this booklet yet. You will do by the next time that we see each other. This is the final topic in Year 10. So you've impressed me by the amount of work that we've done. This final topic is all about electromagnetism and electromagnetic induction. You're going to get two small booklets come through the post. The first one will be on electromagnetism, and the second one will be on electromagnetic induction. Now, today, you haven't got these books, so I can't be expecting you to do the booklet work. But what we can do is start to have a look at magnetism and electromagnetism and electromagnets and where they're used. I mean, they're used in everyday life everywhere. It's a really important concept. So the first thing that I'd like you to have a look at today, and you can do this online. You can write it down on a double-sided sheet of A4 paper, however you'd like to do it. Keep it as a computer copy. Look at how magnetic field lines are created around a simple bar magnet. This is a permanent magnet. It's always got magnetic field lines around it. Now, you could sprinkle iron filings over the bar magnet. You could use a compass that points north, east, south or west. And what you should find is magnetic field lines travel from north to south, and the further away you move away from the magnet, the further the magnetic field lines are away from each other, indicating that the magnetic forces are weakening. There's one side of the magnet. You can obviously do it on the other side as well. North to south, north to south, from north to south, and from north all the way round to south again. And you can see quite clearly that the magnetic field lines are most concentrated around the poles. And that's where you'll get the largest influence of the magnetic field. So let's just go through this again. What do I want you to do? Look at how magnetic field lines are created around a simple bar magnet, and how they are shown, or how you can show them visibly, because you can't actually see these lines. But you can use iron filings or a compass to plot those magnetic field lines. So that's number one, nice and simple. Number two, in 1819, this scientist called Ørsted, accidentally discovered that when current passes through a wire, it generates a magnetic field. This field only exists when current flows. So in other words, it's not permanent, it is temporary. He had generated the first electromagnet. I would like you to find out a little bit more about Ørsted and the experiment that he carried out to show that he discovered this concept of electromagnetism. Now, this is quite interesting if we go all the way back to the beginning. You should know that if you bring two permanent magnets together, like poles, north and north or south and south, they repel each other. Whereas if you bring opposite poles, north and south or south and north together, they attract. Now, electromagnetism uses the interaction between electric current and magnetic fields to produce movement. And you can use these to produce useful devices. We've got a drill here that uses the interaction between electric current, which generates a magnetic field, and permanent magnets. Okay, so using this repulsion and attraction. We've also got some sort of whisk here, and speakers. Remember, speakers move in and out. They all use electromagnetism. So, number 3, look into other appliances that use electromagnetism to work. Basic stuff, you know, it's just generalized work. And then let us move on to the final thing that I would like you to have a look at today, or a couple of the final things. To generate an electromagnet, it's pretty simple. You need an iron bar, that's that there. You need some insulated wire that surrounds the iron core. You need a battery to supply the current, and as a result you can generate a temporary magnetic field. It only lasts for as long as the current is flowing. It's pretty simple to produce an electromagnet. So the final thing that I'd like you to have a look at is this here today. So this is number 4 in our list of stuff to do. Find a suitable picture of an electromagnet made from an insulated wire, an iron nail and a battery. Nice and simple. Explain why electromagnets produce only a temporary magnetic field. That's got something to do with the current flowing. And why steel would be unsuitable for the core. That's the object that is surrounded by coiled insulated wire. Now, electromagnets are used in various devices. Find a simple diagram and summarize the text so that it makes sense to you on the following devices. Okay, I definitely have a look at the scrapyard crane, which is what we've got here. Okay, an electric bell, like a dinner bell or a fire alarm. And then one of these two, either a circuit breaker or a relay switch. Okay, that will do for today's lesson. Well done. By your next lesson, which will be in a fortnight's time, I would have made sure that you have the final 2 booklets to complete the course for year 10. And when I do see you back at school, don't forget to bring these 2 booklets into lessons as well. But until then, goodbye.